Okay, now let's go ahead and use the second fundamental theorem of calculus to try an application. So on page 3, the graph that you're given is the graph of f, but they're telling you that there is another function, g of x, which is the integral of f of t, which is this graph right here, from 0 to x. And they ask you to find a couple different things. So the first thing is, can you find g of 2? So all we're going to do is just use the equation they give me. They tell me that g of x is the integral from 0 to x of f of t dt. So to find g of 2, all you need to do is replace the x with 2. So this would be the same as 0 to 2 of f of t dt. And we learned that as long as the function is above the x-axis, the definite integral from 0 to 2 would just really be the same as the area underneath the curve from here to here. So what's asking us to do is just find this value. I'm going to do it geometrically, and if you do it geometrically, the area of this trapezoid plus the area of this trapezoid should get you to 3.5. Now they're asking you to find g prime of 2. I'm going to start with this again. I need the derivative. So if I take the derivative of g, here's our second fundamental theorem. When I take the derivative this side, I get g prime. When I take the derivative this side, the derivative undoes the integral, and this x goes in for t. So g prime of x is the same as f of x, so g prime of 2 is the same as f of 2. This is the graph of f right here, so what is f of 2? It's just the y-coordinate on this graph, which is 3. So if g prime is f, then g double prime of x should be the same as f prime of x. So g double prime of 2 is the same as f prime of 2. And if I look at this graph of f, what is the slope at 2? It does not exist because it is a corner. Okay, now same questions we've seen before. On what interval is g increasing? So when they ask you about something increasing, you should be thinking, okay, I need to figure out where g prime is positive. But the graph that they're giving you is f. You need to connect it to what f is. Well, g prime, we just set up here, is the same as f. So g prime positive is the same as f being positive. And where is this positive? On the entire interval from -2 to 3. Where is g concave up? So I'm looking for where g double prime is positive. But again, you need to connect it to f because that's what's given. But we figured out from here that g double prime is the same as f prime. So I'm looking for where the slope of this graph f is positive. It is positive from -2 to -1 and from 1 to 2. Okay, last one. Identify any local extrema of g. So I know local maxes and mins can only occur where g prime, which we already said is the same as f, is equal to 0 or does not exist. I look at this graph. This is the graph of f. The only zeros are the endpoints, which cannot be a local extrema. There's no other places in here where I have zeros. Remember, I'm looking for where f is equal to 0 does not exist. F exists everywhere. There's no place where other place where f is 0, so there is none. Let's try one more example, same idea. Here's g of x. It is defined as the integral from 0 to 2x of f of t. So f is given in the graph. So g of 2 is the same as replace the x with 2. So that means this now becomes a 4. So I know the definite integral is the same as the area underneath the curve. So from 0 to 4, that would be just the area of this trapezoid right here. And doing it geometrically, I'm going to get 7 for that value. Okay, now g prime of x. So I'm going to go back to this one and take the derivative. The derivative of g is g prime. The derivative of this side, we take the 2x, plug it in for t, but then we learned that if this is not just x, we have to use the chain rule, so I'm going to multiply by 2. So I'm going to plug in 2 for x now. So this becomes f of 4 times 2. That's what g prime of 2 here is. So what is f of 4? F of 4 is 2. This is just 2, so this becomes 4. Okay, lastly, g double prime of 2. Okay, I'm going to go back to this. You always want to get the general equation in terms of x before you start plugging in numbers. So the derivative of g prime will give me g double prime. This 2 here is just a coefficient or a constant multiple. Just leave it in the front. Now I just have to take the derivative of this. The derivative of f of 2x is the derivative of the outside times the derivative of the inside. It's your chain rule again. So g double prime of 2 would be the same as 2 f prime of 4 times 2. I'm going to simplify a little bit, which is 4 f prime of 4. So I can look on the graph to figure out what the slope of this graph is at 4. Well, at 4, it's a horizontal line, so the slope of the graph at 4 is 0. So this is going to be 0.